Okay, we're going to take a look at the second part of the excellence question. Now that we've got, we know that this equation 9x plus 12y equals p, which is our profit function or optimum function, has the same gradient as 30x plus 40y less than or equal to 1800. Now, that means, we know what that means. It means that we have multiple solutions between 20 and 30 and 40 and 15. But the thing is that we're dealing with whole numbers. Because we're usually dealing with like dolls or or batches of things, so we have to have whole number combinations between 20 and 30 and 40 and 15. We need to find all the solutions basically for excellence between those 2 points. So what we have to do to test the points and turn the profit, we basically have to find all those solutions. So what we're going to do is we're going to take this 9x plus 12y is equal to p, and we're going to turn it into a y equals equation, which we've kind of already done by finding the gradient anyway. So we end up moving the 9x over, and we get 12y is equal to negative 9x. Now, the p is going to be our maximum profit. So if the maximum profit for for those 2 points, 20 and 30, 40, and 40 and 15, I think it was 540. So we're going to actually make p 540 in the equation. We're not going to just leave it as p. So we're going to get negative 9x plus 540. And then we're going to divide by 12, we're going to divide by 12, we're going to divide by 12, and we're going to get a y equals. And we're going to get y equals negative, and it's 3/4, and most of you put it as a decimal, which is fine. And then when we divide 540 by 12, we get 45. So we end up getting this. Now, the nice thing about that is we can throw it into our calculator. And if we throw it into the table function in our calculator, y is equal to negative 0.75x plus 45. Boom. Now, we want to get a table of values so that we can figure out all the whole number positive solutions. So we're going to set the table, and we know that we're going between 20 and 40. So I'm just going to start at 20 and end at 40, because that's the feasible region. That's the only area that we want to look at, and we get a table. Now, we see 20 and 30, that's the solution. But what we do is we go through the table, and we look for whole number solutions. There's one there. 24 and 27. So we write 24, 27 as one of our solutions, and we go back to our calculator and we find another possibility. So scroll down until we get another whole number solution. There's 28 and 24. So we're going to write that, 28 and 24. And so we scroll through our calculator until we hit all the whole number solutions between 32 and 21, between 20 and 40. And we do it again, and keep scrolling down, and you get the idea. There's another one, 36 and 18. So we scroll all the way down until we get to 40. Those are all the possible solutions for between 20 and 40 in our, remember, between 20 and 40, these are all the whole number solutions that are possible between 20 and 40, and you need to find them all, and that's how you find them exactly. And you would list those and say, the multiple solutions are these combinations. Put it in context. What's your context? What's 24? What's 27? Make sure that you write the statement about the possible combinations in context.